Electricity. You think you know what it is, right? I mean, you live inside it. Right now. Invisible stuff is racing through the device in your hands. It's lighting the room you're in, keeping your food cold, warming your coffee, charging everything you own. Electricity is so normal that we stop seeing it at all. It fades into the background, like gravity or air. So let's test that confidence for a second. Explain it to me. What actually happens when you plug something into the wall? Where does the power really come from? What is electricity? Not the word, but the thing. Most people reach for the same safe answers. It's energy. It's electrons moving. It's current flowing through a wire. And those answers sound scientific. They feel complete, but they don't explain anything. They just slap labels on a mystery. Okay, electrons move. Fine. But why do they move? What's pushing them? And how does that push suddenly turn into light, heat, sound, motion, life as we know it? That's the part we quietly skip. Because the truth is, electricity isn't simple. It isn't intuitive. And it definitely isn't boring. It's unsettling. It's counterintuitive. And at its core, it's doing things that absolutely clash with how we think the physical world should behave. But the way we teach electricity smooths all that out. We sand down the strangeness. We make it feel safe, mechanical, predictable. Flip a switch, light turns on. End of story. Except that's not the story at all. What we're really doing every time we charge a phone or turn on a lamp is manipulating something deeply strange, something that doesn't behave like solid objects or flowing liquids. Something that operates through invisible forces, delayed effects, and rules that feel more like magic than machinery. And once you see that, you can't unsee it. So let's peel back the curtain gently, step by step. We'll start with an experiment. Nothing fancy, no lab coat, no equations. Just grab a piece of plastic wrap, rip off a strip, now rub it between your hands fast, like you're trying to warm them up on a freezing day. Then stop. Hold the plastic near the back of your hand. Don't touch. Feel that? The tiny hairs on your arms start to move. They lift. They lean. Some of them stretch toward the plastic like they're being gently hypnotized. You can feel it's something tugging at you from a distance. Pause there for a second. All you did was rub plastic. No battery. No outlet. No wires. No power plant humming somewhere in the background. Just friction. And now this flimsy sheet can reach across empty air and pull on your body. How does that make any sense? In your everyday experience, forces need contact. You push a chair, you touch it. You pick up a book, you grab it. The world you know runs on collisions and pressure, and things bumping into other things. Except, this didn't. Here's a force acting with nothing in between. No rope, no rod, no invisible arm, just space, and yet it works. Most people brush this off instantly. Oh, that's just static electricity. Middle school stuff. Party trick. Not important. Not important. You're watching the very force that holds every atom in your body together. The force that makes chemistry possible. The force that lets neurons fire, muscles contract, eyes see, thoughts form. This is one of the four fundamental forces of the entire universe, casually reaching through empty space and rearranging matter right in front of you. And we call it a trick. That's the real problem. Electricity feels boring now, familiar, tamed. We've seen it too many times. So our brains stop reacting. But what just happened is wildly abnormal compared to how we think the world should behave. So let's slow it down and unpack it. When you rubbed the plastic, you didn't create energy out of nowhere. You moved something. You scraped electrons off your skin and piled them onto the plastic, an absurdly small amount by human standards. But still, just a few trillion extra electrons. And here's the part that really messes with your intuition. Those extra electrons you piled onto the plastic, they hate each other, not metaphorically, physically. Electrons repel other electrons with a force so absurdly strong that our brains don't have the hardware to visualize it. But let's try anyway. Imagine just two electrons, nothing else in the universe. Put them 1 centimeter apart. That's it. The electromagnetic repulsion between them is about 10 to the 42nd power stronger than the gravitational attraction between them, 10 to the 42nd. That's a 1 followed by 42 zeros. At that scale, gravity isn't weak, it's irrelevant. For electrons, gravity may as well not exist. The electromagnetic force completely dominates reality at this level. It's not even a contest. So now a terrifying question appears. If electric forces are that powerful, why isn't everything violently flying apart? Why doesn't matter just explode? Because every object around you, your body, the floor, the planet is packed full of these charges, trillions upon trillions of particles, all pushing and pulling with ridiculous strength. So why does anything stay together? The answer feels almost elegant. Cancellation. Look closely at what an atom actually is. At the center, you've got protons positively charged. Surrounding them, you've got electrons negatively charged, plus and minus, yin and yang. And electric charge follows one brutally simple rule. Like charges repel, opposites attract. The key is this: those forces are equal in strength. The pull between a positive and a negative charge is just as strong as the push between two positives or two negatives. So, in ordinary matter, charges are mixed together as tightly as the universe allows. Protons and electrons locked in an intimate dance, stacked almost perfectly on top of one another. Every positive charge is surrounded by negatives. Every negative is surrounded by positives. And on average, they cancel. The forces don't disappear, but they balance so precisely that the balance is hidden. Matter survives not because electric forces are weak, but because they're locked in a near-perfect stalemate. That balance is the only reason the world doesn't tear itself apart. Those colossal, repulsive forces are being held in check by equally colossal attractive ones. That's why the world looks calm. That's why matter seems stable. On average, everything is electrically neutral. But neutral doesn't mean inactive. Those electromagnetic forces are still there, still screaming, still pushing and pulling with ridiculous intensity. They're just balanced so perfectly that the final result cancels out to zero. And here's the wild part: when the forces involved are that huge, you don't need much to break the balance. When you rubbed that plastic wrap, you didn't move a meaningful amount of charge. You shifted maybe one electron out of every trillion. That's practically nothing. A rounding error of reality, and yet it was enough to make your arm hairs stand up. Because when the baseline forces are enormous, even the tiniest imbalance becomes visible, tangible, undeniable. Once you really absorb that, it rewires how you think about matter itself. Pick up a mug. Hold it in your hand. What do you think you're feeling? You probably say solidity, the hardness of ceramic, the physical substance of the object. But that's not what's happening. What you're actually feeling is electromagnetic repulsion. The electrons in your hand are violently pushing away from the electrons in the mug. They do not want to occupy the same space. The forces between them are so strong that overlap is simply not an option. That's why your hand stops. Not because it touched something solid, but because the electric forces skyrocketed before contact ever truly happened. Your hand never actually touches the mug, not in the way you think. It's all force, invisible, relentless, held in a perfect, fragile balance. There's always a microscopic gap between the atoms in your hand and the atoms in the mug. No matter how hard you press, they never merge. They never collide. There is no true contact. What you're feeling isn't touch. It's resistance. It's the electromagnetic force pushing back. And here's the thought that should quietly but permanently rearrange how you see reality. Every force you have ever felt is electromagnetic. Every push, every pull, every sensation of pressure, tension, hardness, softness, friction, all of it. You have never touched anything in your entire life. Every time you think you're touching something, what's really happening is electrons in your body repelling electrons in another object through empty space. The exact same force you felt with the plastic wrap, just operating at much smaller distances where it becomes overwhelmingly strong. The world feels solid not because matter is solid, but because electric forces refuse to let things pass through each other. Once you see that, solid stops being a property of objects and starts being an illusion created by force fields. Now, let's aim that understanding at something familiar. A wire. Picture a copper wire running through your walls. One end connects to an outlet. The other end connects to a lamp. You flip the switch and instantly, the lamp turns on. So, what just happened? The usual explanation goes like this. Electricity flows through the wire like water through a pipe. Electrons enter one end, rush down the wire, and pop out the other end to light the bulb. That explanation feels intuitive. It's also wrong. Completely wrong. In reality, electrons inside a wire drift at a snail's pace about 1 millimeter per second. Slower than an ant. Slower than the minute hand on a clock. If electricity worked the way we're taught, you'd flip a switch and wait minutes for your lamp to respond. But you don't. The light turns on almost instantly. So, if electrons aren't racing through the wire, what is? At that drift speed, it would take close to half an hour for a single electron to crawl from one side of your house to the other. Yet the moment you flip the switch, the lamp responds instantly. So, clearly, something else is going on. Here's the missing piece. The wire is already packed with electrons. Copper is basically an electron playground loaded with free electrons that are just sitting there, loosely bound, waiting for an excuse to move. When you close the switch, you don't send electrons on a cross-country journey. You create a voltage difference. And voltage isn't motion, it's pressure. Electric pressure. That pressure pushes on the electrons nearest the switch. But electrons don't like being crowded. They repel one another across distance. So, when one electron is nudged, it immediately shoves its neighbor, which shoves the next one, and the next. Picture a long line of people standing shoulder to shoulder. If you push the person at one end, the person at the far end reacts almost instantly, not because the first person sprinted down the line, but because the push traveled through the crowd. That's what's happening in the wire. The signal, the force moves through the wire at nearly the speed of light. Not because the electrons themselves are fast, but because the electromagnetic interaction is. That's what makes the electricity so powerful. You can apply a force here, and something responds there almost immediately, even across enormous distances. But that raises a deeper question. Where does the push actually come from? Let's follow it backward. Your lamp plugs into an outlet. That outlet connects two wires in your walls. Those wires run out to power lines. Those power lines stretch for miles, sometimes hundreds of miles, until they reach a power plant. And at that power plant, something is spinning. A gigantic turbine, steel and copper, weighing tons, spinning thousands of times per minute. That motion might be happening 10 miles away, or 100, and somehow, that spin is what makes the lamp next to you glow. Pause and really sit with that. How does rotating metal in a distant building reach into your home and rearrange electrons in a wire? The bridge between those two places is magnetism. And here's the crucial realization. Electricity and magnetism are not separate things. We talk about them like they are, but that's a lie of convenience. They are two faces of the same underlying force, the electromagnetic force. Electric charges in motion create magnetic fields. Changing magnetic fields create electric forces. You cannot have one without the other. They're tangled together so tightly that separating them is like trying to separate the front and back of a coin. This is the secret behind generators. Inside a power plant, copper wire is dragged through a magnetic field. As the wire moves, the magnetic field pushes on the electrons inside it. The electrons resist, they'd rather stay put, but the field doesn't care. It keeps pushing. So the electrons start to drift. That drift is electric current. That's it. No mystery ingredients. Motion plus magnets plus copper equals electricity. Now flip the process around. Send electric current through copper wire that's sitting in a magnetic field. The moving electrons feel a force. The wire itself gets pushed. It moves, it twists, it spins. That's a motor. Same physics, same force, just run in reverse. Generators convert motion into electricity. Motors convert electricity into motion. And both work only because electricity and magnetism are the same thing wearing different masks. If this feels impossible, good, it should. You're telling me I can move metal in one location, and metal somewhere else responds, even though there's nothing connecting them except a thin strand of copper. Yes, you're telling me that spinning magnets near wire creates a push that races across the countryside and makes the electrons rearrange themselves in my house. Also, yes, and this isn't rare or exotic. This is the backbone of modern civilization. Every motor, every generator, every power grid on Earth. Water falls on one side of a dam. Turbines spin. Copper slices through magnetic fields. Electrons feel a push, and that push propagating through space at nearly the speed of light is what turns into light in your room, heat in your stove, motion in your machines. All of it comes back to the same strange truth. We don't move electricity around like a substance. We manipulate forces that reach across empty space. And we've built an entire world on top of that. Fact, often without realizing how wildly unnatural it really is. That push races through hundreds of miles of wire at nearly the speed of light. It reaches your house, nudges electrons into motion inside a motor, and suddenly your fan spins to life. Think about what just happened. Water falls in one location, metal spins somewhere else, and a motor turns in your living room. No gears connecting them, no rods, no pipes, just thin strands of copper stretched across the landscape. That's not normal. That's absurd. And it gets stranger. You don't even need permanent magnets for any of this to work. Take a simple coil of copper wire, push electricity through it. The moving electrons create a magnetic field all by themselves. Now bring that coil near another coil of copper. Don't connect them. No touching. No wires between them. Change the current in the first coil and suddenly, electrons in the second coil start moving. Current from nothing. Motion without contact. That's a transformer. That's how voltage is stepped up and down across the power grid. That's how electricity travels efficiently over long distances. Just copper, just motion, just fields. Metal talking to metal across empty space using invisible forces. Now here's the realization that quietly flips everything upside down. Earlier, I said every force you've ever felt is electromagnetic. Every push, every pull, every sensation of pressure or resistance. But really think about what that implies. The forces you consider normal mechanical forces, contact forces. Solid objects pushing on each other, those aren't fundamental at all. They're side effects. They're consequences of the electromagnetic force. Electromagnetism is the underlying reality. Everything else is just how it shows up at human scales. When you push on a door, you're not applying some mysterious mechanical force. You're creating electromagnetic repulsion between the electrons in your hand and the electrons in the door. That's it. That's the whole story. The door doesn't resist because it's solid. It resists because its electrons refuse to overlap with yours. Every shove, every press, every impact you've ever experienced is just electric forces, negotiating boundaries through empty space. And once you see that, the world stops being made of things and starts being made of fields. When you walk across the floor, you're not being supported by solid matter. You're being held up by electromagnetic repulsion, electrons in your feet, pushing back against electrons in the floor with enough force to counter gravity. When light enters your eyes, nothing is touching you. You're detecting rapidly oscillating electromagnetic fields that shake electrons inside your retina. That motion gets translated into signals your brain calls vision. Chemistry? That's electrons rearranging themselves under electromagnetic attraction and repulsion. Heat, atoms vibrating because electromagnetic forces bind them together. Biology, just extremely elaborate chemistry, still electromagnetic all the way down. Your muscles move because charges shift. Your nerves fire because electric potentials change. Your thoughts exist because electromagnetic forces choreograph electrons inside neurons. Your entire sensory experience of reality, every sight, sound, texture, and sensation is built out of electromagnetic interactions. And here's the deepest, most unsettling part. You cannot explain the electromagnetic force in terms of anything simpler. You can't say it's like a spring or like a rope, or like pressure, because springs and ropes and pressure are made of electromagnetic forces. Any analogy you reach for already assumes the thing you're trying to explain. At some point, the chain of explanations just stops. Electromagnetism is fundamental. It's one of the four basic forces of nature. You don't reduce it further. You accept it as a brute fact about how reality behaves, and then you explain everything else in terms of it. That's deeply uncomfortable, because the electromagnetic forces act across empty space. No contact, no physical medium, just influence reaching out and doing work. And that clashes hard with your intuition. You didn't evolve to understand forces that act at a distance. You evolved to understand sticks, stones, impacts, and pressure, things that touch. So your brain tries to translate electromagnetism into familiar ideas, even when those ideas don't really apply. But the universe doesn't care about your intuition. At the most basic level, reality isn't made of solid objects bumping into each other. It's made of invisible fields reaching across space, pushing and pulling, balancing and exploding all at once. And electricity, the thing you thought you understood, is your everyday window into that hidden world. Contact is the illusion. There is no touching, only forces. Every time something seems to make contact, what's really happening is electromagnetic fields pushing back across microscopic gaps. Reality isn't built from collisions. It's built from influence. So, if you want to understand electricity really, understand it, you have to tear down your everyday intuition and rebuild it from scratch. You have to accept a stranger picture of the universe, one where space isn't empty but filled with fields, where charged particles constantly push and pull on each other through those fields, where action at a distance isn't a weird exception, it's the default. Once you accept that, the light switch stops being mundane and starts being astonishing. Here's what's actually happening. You flip the switch. The circuit closes. Electrons everywhere in the circuit begin to drift slowly, about a millimeter per second. No electron is sprinting from the power plant to your lamp. Meanwhile, miles away, a turbine is spinning. That motion is driven by electromagnetic forces. Magnets rotate near coils of copper. The magnetic field changes. That change pushes on electrons in the wire. Those electrons shove their neighbors. Who shove theirs? Who shove theirs? The push, not the. Electrons surges through hundreds of miles of wire at nearly the speed of light. That push reaches your house. Electrons squeeze through a thin filament. The filament resists. The electrons don't flow easily, and that resistance turns motion into heat. The filament heats up until it's white hot. At that temperature, it radiates electromagnetic waves. Some of those waves reach your eyes. The oscillating fields shake electrons in your retina. Those electrons trigger chemical reactions. Signals race through your neurons. Your brain interprets the pattern. You see light, from spinning metal to glowing wire to conscious experience. Every single step is electromagnetic. The turbine spinning, electromagnetic forces. The signal racing down the grid, electromagnetic repulsion. The heat, the light, the vision, the thought, still electromagnetic. Electricity isn't just something we use. It's a direct glimpse of the machinery underneath reality, a reminder that the world you experience is not made of solid things touching each other, but of invisible fields in constant conversation across space. The resistance in the wire, electromagnetic forces. The glow of the filament, electromagnetic waves. Your ability to see that glow, still electromagnetic. Step back for a moment and appreciate how ridiculous this is. 200 years ago, none of this existed. No power grids, no glowing cities, no screens, no motors, no instant connection across the planet. The forces were always there, but we didn't know how to speak their language. Then we discovered them. We learned how electric charges move, how magnetic fields twist, how motion and fields feed into each other. And once we understood that, we learned how to control it. We built machines that could generate electricity, send it across continents, and convert it into light, motion, heat, and information. And in doing so, we didn't just invent new tools, we rewired civilization itself. Electricity gave us instant communication, telegraph, telephone, radio, television, internet, all electromagnetic. It gave us artificial light cities that glow through the night. It gave us motors, machines that do work without muscle, without fatigue, without rest. It gave us computation, billions of microscopic switches, delicately manipulating electromagnetic forces to store memory, run code, and create thought-like behavior out of silicon. Every single aspect of modern life runs on electricity, and it all traces back to one staggering realization. There exists a fundamental force that reaches across empty space, and if you learn how to guide it, shape it, and nudge it just right, you can make the universe do work for you. To someone living 2 centuries ago, this would look indistinguishable from magic. So, what is electricity? Really, electricity isn't a thing. It's not a substance. It's not a fluid flowing through wires. Electricity is what we call it when we harness the electromagnetic force and put it to work. And at an even deeper level, electricity is evidence that the world is not what it appears to be. The world feels mechanical, solid objects touching, pushing, colliding. But that picture is wrong. It's a convenient illusion your senses evolved to believe. Underneath, there are no solid surfaces, no true contact, just invisible fields reaching through space, pushing and pulling, perfectly balanced, until we learn how to tip the balance. That's electricity. Not power in a wire, but a glimpse behind the curtain of reality itself. The real world isn't built from solid objects pressing against each other. It's built from fields, filling all of space where particles push and pull on one another across emptiness. When you see a piece of plastic attract paper, you're watching the same fundamental force that makes chemistry possible. When you turn on a light, you're not sending power down a wire, you're shaping electromagnetic fields that already permeate the universe. And once you truly see that, something shifts. You realize the world is electric. You realize forces act at a distance as a rule, not a curiosity. You realize solid matter is just a delicate, dynamic balance of attraction and repulsion, and invisible negotiation happening everywhere, all the time. And then comes the most astonishing part. Humans figured this out. We uncovered these hidden forces. We learned their rules. We learned how to bend them without breaking them. And we built an entire civilization on top of that understanding. That is one of the greatest achievements of human intelligence. So the next time you flip a switch, pause for half a second. You're not just turning on a light. You're nudging electrons into motion across entire cities. You're converting falling water, spinning metal, and magnetic fields into glowing matter. You're commanding forces that act across space itself. You are, in a very real sense, exerting control over nature's fundamental machinery. That's what electricity really is. Not a utility, not a convenience. It's a window into the deep structure of reality and proof that the human mind can uncover it, understand it, and put it to work. That's the real story of electricity. Not comfort, not familiarity. Truth.